In this lesson, we will contrast some of the many differences between humans and chimps/apes. The features we'll be contrasting are the entire skeleton, body dimensions, mobility, sexual dimorphism, female morphology, menopause, brain, face, facial hair, hair color, mouth and throat, and then for miscellaneous we'll look at fairly quickly. So first we'll look at the entire skeleton, body dimensions, and mobility, and do so all together since they're fairly related. Though humans and apes have the same bone types, we both have a rib cage, we both have a femur, spine, so on and so forth, they are of very different shapes, structures, and proportions, especially the skull. As you can see in these images, you have the human skeleton in the middle, the gorilla skeleton to the right, and the chimp skeleton to the left. You see, both skeletons are entirely structured for completely different forms of movement. Humans for bipedalism, which means two-leg walking, and apes for knuckle walking, basically a form of being a quadruped, four-leg walker that is. And you can't have a human collarbone, human spine, or human feet and be a knuckle walker or any quadruped. And you can't have an ape arm, an ape pelvis, or ape lower leg bones, that would be the tibia and fibia, and be a biped. These skeletons have to be complete and completely different from each other. And the skeleton isn't the only thing that's different when it comes to our differences in mobility. Also, humans have Achilles tendons and knee locking mechanisms and a lot more hand mobility all around. Next, look at sexual dimorphism, female morphology, and menopause all together. Just like the first set, they're fairly related. When it comes to sexual dimorphism, which is physical distinction between the genders within a species, this isn't the same for both species, for humans and chimps. It is greater in chimps, meaning there is greater difference between male and female chimps than there are between male and female humans. When it comes to female morphology, female humans and chimps are more different from each other than their male counterparts are. Because come on guys, let's be honest. Here's a picture of a woman and a picture of a female chimp. Now they look more different from each other than us guys do from a male chimp. Hence why the March of Progress image and any variations of it always depict males, because using males makes it look like there's less physiological difference. But if you were to use females, then you'd see that there is more physiological difference and anatomical difference than you think. And then when it comes to menopause, this has only been recently discovered in chimps, like within the last few decades, and it's still fairly different from that of women. For example, chimps' fertility does not start declining until they reach their life expectancy out in the wild, and they don't go through menopause until like 10 to 20 years after that, meaning chimps die. The only reason chimps go through menopause is because they surpass their life expectancy. That is not even close in the case of women. Now, when it comes to the brain, chimps' brains are a lot more gene controlled, while humans are more plastic. So what this means is that the basis of chimp brain functions are mainly just their genes, what their genes encode for and what those things that they encode for do, like the proteins that they encode for. But humans, on the other hand, unlike chimps, our brain functions are mostly based on adapting to our external environment. It has much less to do with what genes we have and what they encode for, what proteins they make. Also, the human striatum, if I pronounce it right, which is that red highlighted area in this picture, They have interneurons, which, by the way, those are nerve cells that connect nerve cells used for the senses to nerve cells used for mobility, or i.e. motor skills. Those interneurons in the human stratum have expressing genes, so genes that are being used to make something, that code for dopamine synthesis. Synthesis meaning basically creating. So our nerve cell type connecting nerve cells do and do encode are being used to encode to create dopamine when it comes to our stratum, unlike that of chimps. And this gives us some of our cognitive difference. So it's a big deal. Also, humans have brain-specific immune cells in that blue highlight area in the second picture called the dorsal lateral prefrontal cortex. So it's just what that section of the brain is. Details you don't need to know. But yeah, unlike chimps, we have specific immune cells there. So that's a fairly major immune system difference. Now, when it comes to our faces, there are about 1,000 groups of genes that are triggered in different ways during the development of facial features. That is a lot of genes, and because it's during development, it's even more significant, because development are the very early and precise steps that need to be done right to get you from A to B. And then when it comes to the positioning of our face from what's called the anterior cranial fossa, which is that green highlighted area in that picture of the skull, ours is below that. Our face is positioned below that, hence why it runs sort of up and down. While chimps and other apes, theirs is positioned in front of that, hence why their faces slope forward. And when it comes to the visibility of our sclera, the whites of our eyes, that also, as you know, is fairly different. Also, humans have about 20 more facial muscles than chimps. It is a major muscular difference. It's nearly double of 10. And chimps don't have that little divot between our nose and lips like we do, which is called the philtrum. And finally, chimps don't really have foreheads at all because of where their faces are positioned, unlike us. When it comes to facial hair, only humans really have true beard, stashes, and eyebrows. As you can tell from the picture of the human in the middle and the chimp on the left and orangutan on the right. And as you can see, out of those two apes, the orangutan actually is much closer to having true facial hair, and yet the chimp to the left is supposed to be much more closely related to us than the orangutan. Now, when it comes to hair color, apes only have black and orange shades of hair. Blonde and brown, at least brown that's not fairly dark or only light because of long-term sun exposure, doesn't really exist in apes, but it does in humans. Actually, humans have a fairly wide range of hair colors and shades, unlike apes. And you think this may be a minor detail, but if you think about it, in humans, red hair is a variation of blonde hair color genes, but apes already have orange colored hair, but no blonde hair genes. When it comes to the mouth and throat and all things around there, as it pertains to the tongue shape, humans have a globular tongue shape. It's round, while chimps are very flat. Also, man's epiglottis, which is the flap at the back of the tongue above the windpipe, it is separated from the soft palate, which is that muscular part of the roof of the mouth. Also, man's lower jaw, hyoid bone, which is the tongue bone, as it's called, and as well as the larynx, which is the voice box, are all separated from each other and are suspended vertically from the cranium by muscles. And this doesn't exist in any other mammal, let alone chimps and other apes. And finally, humans have many structural differences, these just being a few of them, that allow for so many more vocalizing abilities, unlike chimps. And when you add up all the structural differences we have just for having more vocalizing abilities, that creates quite the difference because it affects so much of our anatomy. Now let's quickly go through 4 miscellaneous differences. First of all, humans have what's called a nodular ligament. That's the ligament at the back of the neck right there. Hence why our necks and heads are positioned the way they are, unlike apes. Next, when it comes to eccrine sweat glands, which are the most common types of sweat glands, the ones used for thermal regulation, they are 10 times larger than human beings. That's why you can see a human that looks really sweaty, but not really a chimp. Then when it comes to fat storage, humans store fat in blubber layers under the skin, some of us more than others. And when it comes to chimps and other apes, they mostly store it in pockets between the muscles. Hence why about all of them look very muscular, unlike us. And then finally, when it comes to intestine volume ratio, it's more for the small intestine in humans, and it's more for the larger intestine in chimps, meaning the volume of the human small intestine is greater than the volume of the human large intestine, and it's the reverse for chimps and other apes. And that makes a digestive difference. You know what? Why stop at those contrasts? Let's look at a couple things that we actually have more in common with non-ape species. First of all, our heart and blood which Leviticus 17:11 calls the life of the flesh, is actually more like that of pigs than it is chimps and other apes. Hence why interspecies heart transplants were done with pig hearts and not chimp hearts. And this is the case, even though we are supposed to be far more closely related to chimps, basically genetically the same, and far less related to pigs who have hooves. Also, our friction-ridged skin, which is your fingerprint skin, is seemingly identical to that of koalas, as you can see in these pictures, and incredibly easily distinguishable from that of chimps and other apes. So I'll end this lesson on telling you what the heck the point of this is, which is that there's a connection to the gospel here. You see, man is different from all other creatures because we're made in God's image. And not only is our soul, which is our essence of being, referred to as distinct from other organisms, but also our biology too. 1 Corinthians 15:38-39 says, "But God gives it a body as he has chosen, and to each kind of seed its own body. For not all flesh is the same, but there is one kind for humans, another for animals, another for birds, and another for fish." Also, Genesis 9, verses 5-6 say, "And for your life blood I will require a reckoning. From every beast I will require it, and from man. From his fellow man I will require a reckoning for the life of man. Whoever sheds the blood of man, by man shall his blood be shed, for God made man in his own image." Also, Christ not only took on human nature, but also a human body, and it was the sacrifice of his human body that paid the debt of mankind. Sacrifice of his human body being part of that. Hebrews 2, verses 14 and 17 say, "Since therefore the children share in flesh and blood, he himself likewise took part of the same things, that through death he might destroy the one who has the power of death, that is, the devil. Therefore he had to be made like his brothers in every aspect, so that he might become a merciful and faithful high priest in the service of God to make propitiation for the sins of the people." See, our soul and our flesh coincide together. So if our flesh, which is our biology, our anatomy, physiology, our DNA, if that and isn't that and if it, our flesh, isn't that different from chimps then? If our biology is closely related, if our DNA originates from the same DNA, then that could imply that then our souls aren't either because the two coincide. But no matter what, it does diminish the value and necessity of Christ's humanity if our biology is not totally unique.